Hey, thanks everyone. Happy to be here. Happy to be the third speaker of Aurajoki Overflow. I'm a data engineer, so this topic is quite good for me. The topic will be designing data-intensive teams, which some of you might recognize from book Designing Data-Intensive Applications, which is the holy Bible of each data engineer. You should read this if you work with data. It's 600 pages of really dense information. You will go through it 2 pages at a time, have a nap, read another 2 pages. But it goes very deep. If you ever work with databases, if you ever made indexes, it talks about what actually happens on the file system level, on the binary level. It will explain it all to you. So if you wish to expand your knowledge on that, then pick it up. I will leave it here today, but I will pick it up at the end of the night. So if you want to take a look of it, I will leave it somewhere here. A little bit about me. Lauri Huhta. My handle is @Huhta_Lauri. I'm not too active anywhere professionally. That's my Twitter handle. I have 7 followers and maybe 4 tweets, but maybe we can increase that a bit today. When I actually started working as an adult, my first real job was actually in sales. I was working because sales, as you know, they take anyone and everyone. And having no degree at that point, and not even now, that was a good starting point for me. But I won't say that it was useless for me because I quite quickly moved into business side of things, B2B, business to business sales and marketing kind of stuff. So as a consultant, it's been quite helpful. In 2020 or late 2019, I started working at Eficode, which is quite known DevOps company here in Finland and across Europe. Although my title there was a DevOps consultant, I was doing a lot of data work in there. So I was doing kind of both, but focusing on data engineer consulting, which I'm doing now as an independent, focusing more on strictly data gigs. So I'm consulting as a all-around data worker, mainly data engineering. Hoping for many more years, learning new about data, sharing my knowledge, just being active on communities, and also, again, happy to be here. Let's get to the topic. Why do we need data teams? Like, why should you take initiative in your company to build something with data? And I have 3 answers for this. First one will be really, really boring. Help businesses make better decisions. This is what you hear all the time in the sales pitches. And well, it has its roots. It's if you nowadays, if you are not basing your opinions, your decisions on data, you will be considered that you are making decisions blindly. So it has a good meaning behind this. But most of us here, I think, are technical people, so we don't care about this kind of jargon. So we want to scale companies' data needs. Probably if you work in tech, you are lucky enough to work in somewhat modern data infrastructure. You have a software, and through API, you will call a database, and you're already working with databases. So next step, you would expand your modern data infrastructure to something to like data warehouses or data lakes. But we have a lot of small and big important companies in Finland even who are not even using databases. They are basing all of their knowledge in file-based, Excel-based, tons of Excel files, even in really important places. I'm calling healthcare here. My favorite answer, and what I will always focus on as a data engineer, is to enable company-wide analytics. So I don't want to gatekeep anyone from their own company's data. I feel like it's the data workers' responsibility to make it available and easy for anyone to bring insights from their company data. And of course, nowadays we talk about machine learning, so we are talking predictions also. I will structure my talk today in 3 sections, talking about data infrastructures, data teams, and operations. The area will be highlighted, which I'm talking at the moment, and I'm asking you to leave the questions till the end. I will leave enough time for that. So let's go straight to teams. So this considered to be 3 main types of roles in like modern data teams. The first one would be data analyst, and I will come back to that because it's considered widely to be the entry-level position to these other data jobs. So they would follow this kind of structure, try to get their foot in as a data analyst, and then specialize to either engineering or scientist. And their role is to go through the data and transform it to insights. And the data engineer is then the one who will process or execute the ETL processes. So extracting data, getting it from the source, transforming it, making it usable, and loading it to a database or your data store, whatever will it be. I will go through those in the infrastructure. Then data engineers' responsibility will be to make sure that the analyst and the data scientist have their data available to them. A data scientist, this is probably the role that you have mostly heard of. It's the one that everyone hypes about. They make the machine learning models. They make all kinds of, if you've ever used Netflix and it suggests some movies for you, that's a recommendation system that is a machine learning model. So that is their work. I will go more deeper to this soon. Nowadays, we have refined these roles a bit, or there's kind of like more specific roles in a modern data stack. They don't necessarily follow the paths shown here, but most oftentimes it goes like this. So ML Ops is basically when data science meets DevOps. When you want to bring the development and operations together, bring the best practices from DevOps, like continuous integration, continuous development. Someone who knows how to actually carry the process from start to finish and who knows the data side of things will often work in bettering the ML ops in a company. Then when we've hired a lot of data scientists, because it was all the hype, we might have the data and we want to build these machine learning models. We realized that to use these models in any systems, someone needs to know how to deploy them, how to embed these to the applications that the software engineering teams have built. And data scientist wasn't the one at that point who knew how to do that. They might be really good at making the models predicting from the data, but most oftentimes their skills were lacking into actually putting it to production. So nowadays, learning engineer who will most likely be doing this part of the process. I will dig deeper into the 3 main roles. It will come clear that I don't agree with what people often think about data analysts. What you want, if you would hire a data analyst, you would write a job application and it would say like these things: analytical mindset, problem-solving skills. They need to know how to transform data into business insights. They need to know how to handle the data, make it so usable for them, and then visualize it, because reporting nowadays is really visual process. And yada, yada, yada. And I disagree with this because if you hire someone new in your company and tell them that their role is to analyze the processes and bring the insights out of it, someone new in the company is rarely the one ready to make these kind of insights. They are not familiar with the processes from start to finish. And time again, I've been working as a consultant in many companies. And every time, without fail, the best data analysts have never held that title. They are always someone else in the company. Someone who knows the development process of the software. They know the struggles of the developers. They know the users, they know the landscape, they know what they want and what their problems are. And those people are usually product owners, team leads, managers, anyone who will actually see the process from start to finish and can actually easily bring something meaningful from the data. And if you just bring the data for them, enable them to somehow use it, some kind of a visualization tool, Power BI, whatever you use, give it to them, and they will come up with a lot of good things, rather than a fresh graduate analyst who is new to the company. I'm often, with my opinions, I get into fights. So if you want to fight about this later on, I will be here all night and in hospital. But for now, that's what I think. And data engineer, as I said, I'm a data engineer, so I'm not going to shit on them. But most often, if you are transitioning to a data engineer role from some other role in your company, the best suitable people for this would be usually old school database administrators or software engineers. And only thing I wish that I would have picked with instead of sales as my background would have been software engineering, because those are so close to being data engineers if they are just interested in taking that specialization. They know the ins and outs of the databases. Most of you have probably worked with databases and know how the applications, how the hardware and software works with the database. They are able to execute the ETL process. So, as I said, getting the data, transforming it, making it usable, and loading it to persistent storage. So, and they are able to put this all into data pipelines and automate it. That's basically the role. Has anyone here read the O'Reilly books? So lastly, out of the three main roles, the data scientist. This is usually the most difficult role to fill, because almost always, at least internationally, this will require a master's degree, because they need to have the analytical skills that you would write to the LinkedIn post, but they need to be superior in mathematics. A lot of the best data scientists, or whatever title you hold, if you are building predictions, machine learning models, the best ones I've seen are they have backgrounds from mathematics, maybe biology, chemistry, neuroscience, because they know the theory behind it. Because most machine learning is linear algebra, and that is just really good mathematics. So if you give them the tools, just if they learn the basic of programming, like just a little bit of Python, they can execute that mathematics that they know, use the data, and build the models from that. So they will always know what's actually happening under the hood. Let's move to the data infrastructures. We will start simple. I'm generalizing a lot of things. And if I lose you at some point, I don't blame you. But at the top of the page, you will always see the problem or like the framework that we are using or adding. If you just remember those, that will be enough. But most companies, even the simplest ones, the data infrastructure in the point of view of the data looks something like this. Data comes from the API. You get it from there. You load it into a persistent storage, which is a database in the middle. And someone wants to get insights from it. You have a analytics tool, something to visualize it, something to crunch some numbers on it. This can take you really far, because you can load database full with data and use it to a reasonable scale. But in real life, things get a bit more complicated. You get more users. So you never want to burden your operational database with the users, which on this point is the master database. So, and of course, we see that the users and analysts are craving for the data. In real life, no one would let them to get it straight from the database, but I'm simplifying just for this graph. You want to build another place for them to get the data. This is quite simple, especially in cloud environments. People have done this because if you work with at least AWS, Azure, you have a database there. Usually read replica, which is just another clone of the database that gets the data that is inputted into the master, and it's basically a clone from the main database. In cloud environments, creating this is often a click of a button. Of course, you can configure it further, but they made it really, really easy. So if your users are burdening your operational database, there's no excuses to not create a read replica for it, because then the other one can be tuned to be able to sustain heavy write loads, and the other one can sustain heavy read loads. So there's really a good reason to do this. Well, you have more users, but if you have more data, we are introducing the data lake infrastructure. So the right side of the picture stays the same. Left side of the picture, we've introduced more sources of data and a data lake, which is the colorful, wavy container there. For the longest time, I was wondering what the hell is a data lake? It's such a, well, now that I know it makes sense, but it's kind of like a nice name for something really simple. It's nothing but it's only a file storage, nothing else. If you are working in AWS, S3 will be your data lake. If you are working in Azure, blob storage can be your data lake. You can have a server that can be your data lake. It's as simple as that. It's a landing zone for your raw data. Traditionally, that data would be JSON files or CSV files, because those are the most easiest to use. They are readable, and most often, if you're working with APIs or software, that's what it's going to give to you. Nowadays, we, especially in data analytics and bigger scale data processes, there's other file formats that you might want to use, because CSV and JSON, they are row-oriented data formats, which means that when you write a CSV file to a disk, and say the CSV file has 3 columns, it will go to the first row and write the first 3 columns. Then it will go to the second row and write them next to that one. But when analyst comes and loads that data, they want to say we have gigabytes and gigabytes of weather data, and we want the average for the whole year. We only need the 1 column, because if the file is already structured in the way that it has the 1 year, we only need 1 column. We can read it and take the averages of all the numbers that we see in there. So nowadays, you would have multiple other formats which are columnar, because the analytics needs are moving to that. Because when it's columnar, it's all in the same place in the disk mostly, and it makes your processes way quicker, and they come usually with some kind of compression system optimized for the files format that can save you a lot of space. And now to explain why would we even use a data lake, now that I explained what it does. Because we had a picture just before this. We are feeding the data into a database. Isn't that what database does? Holds our data. But when we have way more systems where we are getting it, we are getting way more data. The normal databases may get overloaded, and it can be messy to have all that data there. But also, when we have tons and tons of raw data, it's way cheaper to hold into a file storage than maintain a database in cloud or on-premise that is suitable to hold that data. and actually use it. So we are expanding into a data lake that can hold a lot of our raw data, and we can build around it when we need to use it. So we replaced the database connection with the ETL there, and that extracts it from the data lake and puts it where our analytics system uses the database. So a lot of data, you might consider storing it somewhere in the raw format. And this is where I might start losing you, but no worries, read the header and we are all set. What if we start to need real-time data? Everything else is the same again. The bottom line is the only new thing. We have a huge server rack that we have way more nodes on our software that produces way more data that we need in our operations. And we need it now. If something bad happens, we need to have it in the reporting system immediately, real time or near real time. And everything else that we've done before this, if you build systems, extract code with Python, any language, or there's even a lot of services to extract data from all kinds of services, it's usually periodical. So if you need it now, you would think about streaming data frameworks. One of the most popular of these is Apache Kafka. It's basically just a messaging queue, which, to simplify it a lot again, you have topics in there, you are pushing data from the data center server rack to the topics, and whenever you need it, you can subscribe to it. If your analytics needs it, we get it from there. And there's a live connection. When new data comes in, you get it and you put it to analytics. You can still keep the data in there. You can still load it to the data lake. There's no limitations, but there's a lot of different needs always. So real-time data, consider streaming. There's one more layer to this, and that is heavy transformations. When you are doing a lot of computing with your data. Now, the change is on the top. The example I'm going to use here is Apache Spark. And this is Apache Spark is a parallel computing framework. So what it means that instead of having a machine or your data scientist trying to crunch that 300 gigabyte file and make something out of it, well, if you are a good enough developer, you know how to read the actual file. But the most common question that I see in the data science Discord is, why do I run out of memory when I read the CSV a 300 gigs file? So you could do that, but in a modern framework, there's way better ways to do it. So how do you deploy Apache Spark? You build a cluster. So a cluster of machines that will do the computing for you. So when you get that huge file that you, in a reasonable time, wouldn't be able to process and make something meaningful, usable out of it, you feed it to the cluster, it does a map-reduce type of operations to it. So it's separated for all the nodes in the cluster, calculates it, and then produces a number of series of numbers, a result, something usable out of it. And you can load that to a data warehouse or your existing database. Data warehouse is another modern technology, which is basically it. When you are using it, it works a lot like a database, but you can scale it very, very, very easy. Say a Snowflake that you can use. It's a data warehouse that you can use in AWS, Azure, and GCP at least. I don't know if it's available elsewhere. With just a single query, you can expand your size of your workers, you can scale it bigger, do your processes, and then scale it back down again in an SQL-like command. So that's where you might introduce data warehouses. I'm putting a lot of things here and not really going into detail, because it's good to know about this, but I'm talking for 35 minutes, 40 minutes. We can't go any deeper on these subjects than this. But it's good to know these layers of what you would do. If this happens, then you would do that. More users, more data, heavier computing, a lot of data storage. Let's move to operations. This is probably really familiar to all of or most of you. We have environments where we develop or where our code goes through. There's development environment, staging environment, and production. And development environment doesn't really differ. We code like any other, just our focus is on the data. But where the main difference is the staging environment, because while we are doing all the testing, unit tests, or the integration tests that we would normally do to our code, we also need to make sure that the data that we are outputting is of good quality. And there's two main things that you need to check there before you can elevate the data with the code to the production. You need to check for it, the quality and the integrity. They sound like the same thing, but there's a slight difference. Quality checks that the data meets the standards that we've set in the organization. So it can be what the data can be, is there null files, how do we handle some cases. But integrity is more of a question, how should the data look? Or like what is the characteristics of the data? And I will go to that soon and introduce a framework that is really very good for it. And only after those data tests, it's good to go. You can put into production your data pipelines. You can have data files in like ready to use data files in the production that your analysts can use and the scientists can use. So a lot of familiar stuff if you worked with these three environments or even more environments, but there's a little extra layer to it. Big thing that hand wavers like me like to talk is data governance and the lineage of the data. So this is something that is quite important to start early on when building your data infrastructures. You can do this already when you have the database and nothing else. It's good to document the processes and have clear rules and documentation of what data is, what data exists, where it is, and what can we share. Because like the most common problem is, especially for non-technical people, like they might not know what there is to use. They might know what to use data for, and they could imagine that, well, there must be data existing for this. But if there's no documentation or any governance, any rules, they don't know how to assess that. So this might sound basic, but this is lacking in many organizations. And of course, a lot of us work with clients, so we need to know what is okay to use and what not. What kind of transformations can we maybe apply so we can use our data in a wider use cases. Data contracts are a quite interesting concept that sound good on paper, but I've not seen it used in many places, but I'm interested to give it a try. Basically, when you are sharing data across teams, you would settle on a contract with the data team and the software team. Like, what do they expect from the data and for how long? When should the data be deleted? And what are the characteristics of the data? This could be just a documentation. This could be a JSON a config file, any kind of file, because if you actually go over these, it's then easy to have some kind of ground point or beginning point for your testing. Because when you're testing, you can in the contract see, does this fill in the needs that team needs? There's a huge use for this. I think it's in Airbnb. They call it a Midas framework, which is all about testing and making the contracts. And they know that when it has the stamp of approval from that testing framework, then it's going to be good and no one probably is going to delete your data pipeline. So something like this is something that you could consider. Data lineage is probably one of the rooting from a problem that many of us have seen. Say you have a lot of tables in your database, a lot of columns, and the columns follow some kind of a structure. And there's tons of teams that expect the data to be in that kind of format. So data, and when you publish the data sets, publish the data pipelines that then produce the data, you might not know who is going to use it. And comes a point when you might need to deprecate some data, or you might need to change something or improve something. You need to know who actually uses the data, who's assessing it. So some kind of following system that sees, so let's say it's easy from logs. If you have a database, you can get the logs out of it. Who has queried this table in the past 90 days? And have they queried this data? These kind of systems are in data lineage. Of course, there's some that are usually built in softwares, reader schema, writer schema, which means kind of in the column level what softwares, when they talk with each other, can expect from the data. Because when this is then executed well, it's easy to make backwards compatible versions of your data sets. But of course, this is really hand-wavy stuff. You don't see this often. If you see, it's usually a mark of a good data infrastructure. And there's actually someone else leading it and not just data engineers running around with their data. I don't know how I'm doing with time. Okay, that's good. For the end, I will go over a few of these frameworks that talk about these topics some of these topics that I talked earlier. These are something that I use or keep an eye on that have really good funding for the future, and I'm expecting to see them used more widely. The first tool is for the integrity testing. It's called Great Expectations. And well, it's basically what can I expect from my data after it has gone through the testing. You can use it in different ways, write config JSONs, interactive workflow in Python. There's profilers, because like these things are quite simple. Like check that it's in between these values. But everyone, like when I go to a new company, I need to write that again. Make sure that the data is in these ranges. And that's a simple thing that everyone needs to write time and time again. So it's good to have these frameworks that actually do it, and they have the profilers that actually automatically detect the nature of your data. So you can use that as a starting point for your data integrity testing. Of course, there's custom scripts too that you can use. And in the simplest format, it looks like this. Expect that column values are between 60 and 75. Use that room temp column and have some kind of threshold for it. And it might give something out that, well, you are not passing it because over 5% values fall outside of it. And Great Expectations give you a nice report from it. And this is something that would happen then in your staging environment. You have failing tests there, even though, because in traditional testing, the code might be good, but the data is bad. And this will bring that to the table. And this data is then not good enough to elevate to the production. This is of course open source. I can, yes, you can check their websites. Great Expectations is some classical book, so you have to Google Great Expectations data to find this page. But they have 184 expectations, and some of these go really specific. Let's see, we have expect column discrete entropy to be between something, or just a easy ones, expect column average to be within range of given point. But they can go really deep, like if you have location data, latitude and longitude. Someone has already built a module for checking that it's in between, it's in this area or between these areas or not too far from this area. And that can be an expectation that you test your data for the integrity with this tool. So there's a lot of these, and as I said, these are open source, so you can develop your own and start using them alongside of what they serve. And they have connectors with basically all the most common data environments or data frameworks: Pandas, Spark, SQLite, Postgres, and all the main databases. So that is something that I wanted to bring up in that if you are not using testing in that sense, then I would encourage you. Which button do I press? Great. Another one, operational tool, is dbt. Again, dbt means something else. So it's a database tool if you write it out. This is something that you would use for the T of the ETL process, for the transformations. When your raw data is already loaded somewhere, then you would introduce dbt. And again, these are many things that many of us have written already, but it's an open source framework for stuff that everyone needs to write over and over again, so we don't need to design the wheel again. But of course, it has a really good funding behind it. It has a good community behind it. So it has a lot of features that help you alongside of this process. As I said, it helps with the operations. This is a lineage graph that you will then get out of your dbt workflow. So if I explain the picture, the red ones are the tables and the data that you are going to use. The blue ones are transformations from it. They might be database views that has already the data model that you need. They have calculated, or they have the customer dimensions, the orders there, and then you can expose that as a dashboard. And on the right, what you see is a documentation that the dbt framework encourages you to do when you build this. Because now when you open this, you see what connects to what, but also there's a description, what it is, where you can find the maintainer, what does it depend on. So having these kind of little tools to help you will make it so much easier, because now non-technical people can open the lineage graph and they know what metrics they need, but they want to change the underlying structure. They know who to contact. So even though in a small company, this might sound like obvious that, well, you just contact the data team. But when your scale gets bigger and bigger, it's really difficult to find the person, or maybe the person doesn't even work in your company anymore. dbt, you write basically like you would write SQL. It's just structured in these configuration files more so. So something that I have used before, let's see this file. So it's a bit of configuration. Yeah. So we have configurations. This is going to be an incremental model. Incremental model means that when we load the data, we do the extracting and load it somewhere in the storage. We want only the differing data or the new data. If we did this process a day ago, we are only gonna move the new data, what happened today. So it's an incremental model. And if you ever build any kind of data loaders, you need to write this yourself. But it's in there, so it's really easy to use. Next one, it's just SQL that you might see. It's a common table expression passing a JSON file or like a JSON column from another table. It's not doing anything fancy, just extracting the data from it. And at the end, you can see if it's incremental, then it will check that the data is the new data. So you refer to the updated column, which is column from the SQL command. So your workload is not going to be any different. Because if you don't do an incremental model, you would just have, you might not even need this. But it's nothing new to learn. Yeah, so those are the two frameworks that I would encourage you to keep an eye on if you work with data, and maybe try to implement them. Like, get some idea of data testing, or get some idea of version controlling your data pipelines, have some configurations behind them. So conclusions, what I think are the most important in this hand waving lesson is that enable analytics across the company. And I said that I hate the analysts because they are answering analytical questions rather than building analytics frameworks that anyone in the company can use. So I think the main focus is to share the data to everyone, to places that is easy to use. And these processes and these frameworks may help with that. Introduce the data testing early, even though these are tools that are used in sold for data warehouses like the DBT. It talks about data warehouse, and not many of us use data warehouse. We just have databases. You can use it in a smaller scale, so you can start early. Like just trying to put that point that maybe tomorrow you want to try this out. And as I said, version control everything, because data people are the worst at version controlling. They go to the database, they change a column, and it's changed. No one in the code knows. Well, then you have to go to the code and change the column, but the process has already happened and it's not in it hasn't gone through the testing. So make everything go through version control and introduce some operations to it. That was me. Thank you, and see you all in Hospoda tonight.
We have room for a couple of questions, if anybody has a question for Lauri here.
Lauri? Yeah, I can shoot ask. I've been building a data team the wrong way. I started with data scientist and figured out all of the hard things the bad way. So I've been there. The question, any advice for data cleansing and anonymization at that part? That's a big thing, at least when I work with these type of things. And it wasn't easy to figure out what's the best solution, what tools there are, how to approach the cleansing and anonymization.
That is one topic that I've battled with, because I worked in healthcare. I currently work in healthcare, and I need to do the exact same thing. To my knowledge, someone can correct me, but there's not really good tools to actually that would clean your data or anonymize your data like from the get-go. Because oftentimes, probably in your case, a lot of the anonymizations are just business logic. So if someone knows, I would be happy to know, but these things are really specific to each company. So well, you can introduce it to the processes of any where you do. I would do it where you do the data processing, and then build some kind of testing to make sure that at the end it's clean then.
Kind of an out of scope question. My background is more on the business development side and sales side, but as you said in the beginning, your background is in the sales as well, so you must have some sort of insight on this part. I think that the business and especially like sales needs to support and be a support function for all the specialists in the company. So how do you see, for example, sales, how they can support the specialists in data teams to do their work?
I think it's two-way street, because even the salespeople would benefit from the data. And I mean, it's a lot. I don't know the context. I mean, what your sales process is, because I worked in data sales, and I don't know where I would need the sales, but I know that the sales needs us now with the data. So I would give them to that, because their operations are they could heavily benefit from the data, but there's not really anything. So I would build something like that for them and introduce them to your processes. I don't know what they are selling, like if they are selling consultants or the product, but if you are working with them on helping them, they must get something out of it, and they would be more familiar with like doing their work that benefits you then.
From the back. Yeah, so if you're in a situation, hypothetically, where you already have a team...
Your friend?
Yeah, that's your friend. If you have a team already that has like an established data science team, but they built it kind of in the exact way you shouldn't, then what are some advice for like unraveling that, and can even someone who doesn't have that much experience with like data science or data engineering even help with that?
I'm guessing it's a... Oh, no. I'm guessing it's a hot mess and you don't know where to even begin, right? Oh, sorry, I forgot. So, I mean, even though are not from the technical background or not a technical role, you don't have you can touch the code. All these hand wave things that I mentioned will help with that. If you go with them to ask, where do I get that data? What can I do with it? How is it accessible? They need to give you an answer, and the answer is documenting it somehow. So documenting the data, having some kind of clarity, what is in where, the data governance of it. And then if all their transformations, all the actual data pipelines and everything is just Python code or code that executes in a timely manner somewhere, make them document those and introduce some tools that will give a clarity that DBT will give a good version control to your data pipelines, and Great Expectations will show like the structure of the data. So making them accountable for their work, and that everyone knows what their work is.
One more question.
Yeah, one question about data migration. So often software projects have some kind of data migration activity. So what is the size of the project or amount of data that you'd consider using these tools that you presented? Or how much data do you need to have, rather than writing your own kind of scripts to parse data?
You mean like migrating your...
Like a legacy system to a new one? Like are these tools usable for that kind of scenario?
I mean, as I said, the tools mentioned will work like in a small or big scale. Of course, the migration process well, I can't really say about that, how much work that is, without knowing their infrastructure. But if it's like as I said, what is the starting point? Is it usable at the moment? Would you benefit from having clarity to do it and having these more DevOpsy kind of ways to bring it? So should you even start with it? So I'm guessing it would be yes, but I don't think the data amount matters whether you choose to do it or not.
Let's give a big round of applause for Lauri.